So this is our integration today. This is an advanced integration, and our question is 1 over x plus 3 root x plus 2 dx. This is our integration in question that we're supposed to solve today. Beautiful. So we're about to set the ball rolling. Okay, so let's open a new page. Okay. So the question given is integration with partial fraction. With partial fraction. Such a beautiful question. Such a beautiful question. So the question says 1 all over x plus 3 root x plus 2 dx integral. So this is what we're supposed to integrate. So we have to try as much as possible to break it down. How do we integrate this? Can we say all this we can simplify by taking the x out? No, that will be more complicated. So if we decide to break this integration down, then we say let okay, u to be equals to root x. Okay, so if that is the case, then let's square. We'll square both sides of that. This one, then u, this will be u squared is equals to x. Then again, we can differentiate this. So we have 2u du is equals to dx. So this is the future. 2u du is equals to dx. Now, by inspection, you can see that these parameters that I've separated will help us through substitution to be able to break the equation down. What am I saying that? Let's see. So if we substitute this ones into the integral, then we are going to have an integral 1 over x is u squared plus 3 square root of x is u plus 2 dx. Beautiful. So this is our integration. And if we look at the denominator, okay, you can see that we can factorize. We can factorize the denominator. Okay, so then it becomes the integral 1 over u plus 1 and u plus 2 dx. Okay, so if you look at this, you see that we still have dx here. Our dx is here. So this is our dx. So by substitution back into the equation, then our expression now is going to be, this is equals to the integral 1 over u plus 1 and u plus 2 dx. Now we know the x is 2u du. And because of that, we can write our integration. Let's bring 2 out. 2 integral, okay, u du all over u plus 1 into bracket u plus 2. So this can help us to solve the equation. So let's prepare our partial fraction. Let's say partial fraction is PF. Okay, so this means our equation u plus 1 and u plus 2 now will be equals to a u plus 1 plus b u plus 2. Beautiful. Isn't that beautiful? Okay. If that is the case, then we have to be able to multiply so that we'll be able to solve it. So we say multiply through by u plus 1 into bracket u plus 2. So when we do that, this will cancel this, so we'll be left with u equals to, this is a over u plus 1, multiplying this, okay, once again the u plus 1 will cancel u plus 1, so we're going to have a u plus 2. Yeah, consequently, this would be u plus 1. So we have this equation. So we can solve this to be able to get the variables a and b from our expression. How do we do that? Let's break it into cases. Okay, so the first case 1, and yeah, so case 1, we're gonna have, we say when u is equals to -2. Why have I chosen -2? Because when I replace -2 in the u here, it will neutralize itself, so that I'll be able to work out for the b. So when u is equal to -2, this becomes negative. This one becomes negative. That's u -2 is equals to a out -2 plus 2 plus b, which is -2 plus 1. Okay, 1 u is 2. Okay, so -2 means this will be 0 plus negative b. This implies that our b is equals to 2. We shouldn't forget that. So let's highlight this one. Okay, so we know our b to be equals to 2. Now we gotta go back and do case 2. So our case 2, once again, case 2, we say when u is equals to -1. Okay, this implies -1 is equals to a, okay, -1 plus 2 plus b, okay, which is -1 plus 1, and this will be 0, and this will be a, okay, and this is -1, meaning this implies that our a is equals to -1. Okay, so once again our a is that. So we have been able to get values for a and b. We should bear in mind that our integration, okay, was to out the integral, as we did the partial fraction. This will be u plus 1 plus b u plus 2, all into bracket, du. So this is the integration in question. But we know the respective values of a and b. So we're going to substitute back into the equation, into the integration. So substitute a equals -1 and b is equals to 2. Okay, so this have to go back into this. Okay, beautifully, since we know that 2 out integral all our a is -1 over u plus 1. Okay, plus b, which is equals to that is what, 2 all over u plus 2 into bracket du. So having this means we are gradually getting closer to the final destination. So we have to do something. So we know that we can split this integral. Okay, so when we split this, we are going to get 2 integral -1 over u plus 1 du plus, okay, and the next one is integral 2 u plus 2 du. Okay, bear in mind this 2, there should be 2 over here too, because there's 2 out. Okay, so this, we can now integrate this. We can now integrate this expression. So let's see. Now our 2 is out, and minus will affect it. Okay, so this we have a -2 out, and this will be natural log of u plus 1 plus natural log here 2 and 2, that will be 4. So 4, the integral natural log of u plus 2. Okay, u plus 2 plus our constant. So this is the integral. Okay, this integration integrated to this point. But we know that our u was equals to square root of x. Our u is equal to square root of x, meaning that we have to put square root of x in place of wherever we see u in our expression answer. So now -2 natural log of u plus 1. This time around is going to be square root of x plus 1. Okay, plus 1 and plus 4. Okay, natural log of square root of x again over here plus 2 plus c. So this is our answer. Well, thank you very much for joining us. I think we have to go up and recap what we have done so that if anybody can have questions, they can throw it onto us. So we go up here. So this is the equation in the first place. It was given as 1 over x plus 3 square root of x plus 2. We substituted u to be equals to root x, and when we square both sides, we had u squared to be equals to x. That we differentiated this. Then we had 2u du equals to dx. Why did we differentiate it? Because we have dx over here that we need to substitute dx in place. So now after that, we substituted all the respective parameters into the expression, initial expression. So that gave us the integral all over 1 u squared plus 3u plus 2. Then we factorize it. Okay, that gave us u plus 1 plus u plus 1 into u plus 2. Okay, so the integral eventually become the 1 over square u plus 1 into bracket u plus 2 times 2u du. And this was the summary. Okay, the summary of the simplification. Simplification. Well, we took u over u plus 1 to construct a partial fraction. So our expression, as you can be seen, is equals to a over u plus 1 plus b over u plus 2 equals to the summary of the simplification. Then after that, we multiply through by u, the product of u plus 1 and u plus 2. Then we got to this equation, which is u is equals to a out u plus 2 plus b u plus 1. Then we created cases. Okay, the first case is when u was put to be -2, we were able to calculate to get our b to be -2. Similarly, when u was -1, we were able to come out with our a to be -1. Okay, then this is our partial fraction. We substituted back to the integration. That's how it was. Then after that, we replaced a and b respectively into this, and we achieved this. 2 out -1 over u plus 1 plus 2 u plus 2. Okay, so this is where we got to. And we realized that we're getting closer to our destination. Why? Because now we can separate the integrals. So we separated it. Okay, so as you can see, this is 1 and this is another 1. Okay, now we know that 2 is going to multiply the -1. So this -2 came out. So when we have 1 over u du, that when we integrate it, we have the natural log of u plus 1. Okay, the same way, this 2, multiply this 2, and we have 4 out integral natural log of u plus 2 plus c. Bear in mind that initially we said let u equals to square root of x. So they will substitute it back to our final expression, and that gave us the answer. Well, thank you very much. Please subscribe to the channel and hope to see you around again. Bye.